So today's topic, sequences, is one of these topics that you actually probably already know quite a lot about, but we are going to make your understanding of these both deeper and extended, because we're going to talk about some things we haven't talked about before and make sure you really thoroughly understand what sequences are. So by now, probably everybody has a pretty intuitive understanding of what a sequence is. So for example, I could have a sequence that goes 1, square root 2, square root 3, 2, square root 5. And you would understand that that's a sequence of numbers, and you'd be able to predict the next value. You could tell me what the next term is. You could tell, if I said, what is the 100th term of this sequence, you would be able to tell me it's 10. You would be able to tell me the sequence is increasing, that it is infinite. So those are things that you can say about it. All right, but what actually is it? What actually is a sequence? That's a question that you may have had addressed before, but maybe not so thoroughly. So one of the things about sequences is we have these numbers here that you can see. These are the values of the sequence, but there's a hidden variable here. There's a variable you don't see so much, which is that each of these values of the sequence has a place. This is the first term, the second term, the third term, the fourth term of the sequence. So there's another variable lurking here. We usually call that variable n. And then we can call the sequence values a sub n. So the variable n is usually called the index variable. It doesn't have to be, but that's what we often call it. And then the a sub n is the values of the sequence. So what you can see now is that we have an association of numbers. And in fact, it's this association that, square root 3 with the number 3 that makes square root 3 the third term of the sequence. And that's the difference between a sequence and a set of numbers. So the fact that it's a sequence, it goes in a certain order, that all comes from the association with another variable, which is a natural number, a counting number, 1, 2, 3, 4, 5, that establishes an order in which they occur. So the order is established by another variable. In fact, the fact that you could really write these as a sequence of ordered pairs, really as a set of ordered pairs, and then you could change the order of the ordered pairs, so to speak. So you have the ordered pairs, for example, 1, 1, 2 square root 2, 2 square root 2, 3 square root 3, etc. But you could rearrange them order-wise. So so you could put the 2 square root 2, and then you could put 10 square root 10. You can put them in any order because this is a set. This is a sequence. So in a set, the order doesn't matter, but in the set, we can sort of preserve the order by associating each number with another natural number. So a set of ordered pairs should remind you of something. So what this really is, a set of ordered pairs is a function. So actually, a set of ordered pairs in general is a relation, but if we have the special condition that every x has a unique y, in other words, if I associate x with y1 and the same x with y2, then that y1 and y2 have to be the same. So I never associate the same x with different y's. Well, that happens here. I can't say two different numbers are the third number in the sequence. So there's a unique association of the position with the value, the index with the value. So in fact, we can say this, this is an addendum to your videos for today. Sequences and series. A real sequence is what we're going to be talking about. It's a function. And it's a function whose domain is the natural numbers. All right, so these are the domain variables up here. These are the range variables. All right, and whose range is the real numbers. So I can have my values for a sub n could be things like, negative pi over the square root of 7 or something like that, any real number. And of course, you can create complex valued sequences as well. We're not going to do that, but you can. So that's the range for us. It's going to be real numbers. That's why we're calling it a real sequence, because the range is real numbers. But the domain is always natural numbers for a sequence. The domain is natural numbers. All right. So then with that in mind, a sequence like this, we can write different things, we just beware of the notation. So for this particular sequence, we can say a sub n equals the square root of n. That's a common way to write that sequence. We can also write we'll write a sequence using set brackets. So this looks like a set, but then we say n equals 1 to infinity. And now that's a sequence of numbers. And so then in this particular case, we're talking about square root of n from n equals 1 to infinity. So this is any sequence of numbers a sub n as n goes from 1 to infinity. This is the particular sequence that we wrote here, square root of n as n goes from 1 to infinity. What else can we say? So we can say things, like a sub 100 is equal to 10 for this particular sequence. All right, so those are some things about sequences. So next up, we're going to talk about some special sequences and some properties that they have.